days remaining, so please be concentrate. And today's topic CNN covered by the Mallika ma'am. So without wasting our time, I request to Mallika ma'am, today's speaker. So please start our lecture, ma'am.
Okay, sure, sir. Thank you, sir.
Okay, thank you, ma'am.
Okay, so first of all, I'm going to share my screen. My screen is visible.
Yes, ma'am. Your screen is visual, ma'am.
Okay, sir. So our today's topic is convolutional neural network. So before that, I'm going to ask you some questions, or I'm going to tell you something that we have previously studied. So we have started with Python programming language. After that, how to write codes in Python. You have covered these topics. After that, we have started artificial intelligence and deep learning. In deep learning, we have seen three things: ANN, CNN, and RNN. So artificial neural network is covered by IELTS, and now I'm going to start with convolutional neural networks. So till now, all the participants, do you have any doubts? Anyone? Hello. Okay, so shall we proceed?
Yes, ma'am.
Okay, fine. So now what we are going to learn in this session is what are convolutional neural networks, what is convolutional operation, what is Relu layer, pooling, flattening, full connection, and summary. So these are the topics we are going to cover in today's session, and extra is softmax and cross entropy. So now you all are familiar with some things like what are images and how do we perform operations on the images. You all are familiar with these things? Hello.
Yes,
am I audible? Okay, fine. Now, what we are going to do in convolutional neural networks, we perform operations on the images basically. The operations are performed on the images. So you can see my screen, you can see a particular image here. What do you visualize by seeing this particular image? Anyone? You can see two faces or only one? Hello?
two faces.
Yes, two faces. How one face is one face is in the right side and second one is frontal face. Am I right?
Yes,
So
sir.
what does this show? This shows that this is the visualization or the basically how we see a particular picture. How you recognize in this picture is like for one time you are seeing it in the right side and second is the frontal face. You are seeing this picture. Same as the convolutional neural network is also created, that how our human brain recognizes a picture and it gives predictions basis on that. Is it clear? Hello? Yes.
Yes, ma'am.
After that, again, you can see a picture. In this picture, what do you see? There are two faces. Can you see that? Anyone? You can just tell what you are seeing in this particular picture, what you are recognizing, what you are thinking after seeing this particular picture. A girl? Hello? Let's make the session some means interactive. Please give the answers. What you are seeing in this particular picture? Can you tell me? Anyone?
Yeah, it's a face.
See, it's a face. Yes. See, in this particular picture, there are two faces. One face is of an old woman and second face is a girl. You can see that. See, this is only I want to tell you this, that in particular convolutional neural network, we recognize the things on the basis of the visualization. How we visualize some things. आप किस किस तरह से basically चीजों को देखते हैं, ये convolutional neural network होता है. Okay, you select the features. We are selecting the features. In this particular image, you can see a girl seeing behind the particular scene. Is it correct? And one particular old lady smiling. You can see two faces here. So this is the feature selection we do in convolutional neural network. What we do in convolutional neural network are we select the features of a particular face and train our model on that. Is it clear? After that, again, I will show you a picture. Just 1 minute. Yes. Now, what do you see in this particular image?
The face
Yes,
of
anyone?
some duck-like structure.
Yes, no. But again, there are two pictures in this particular image. Can you tell me? See it from the right side. It's a rabbit. You can see that. Can you see this? It's a bird and a rabbit in a particular.
Rabbit,
Yes,
yes. Yes.
yes, a rabbit and a bird. So this is what I want to tell you, that in the a particular picture, how we select the features, it depends on us. How you visualize a particular thing, it depends on us. So in the similar way, we are going to train a model which will look a particular picture like we are looking into it, and it will recognize the things and predict the particular output. Is it clear? You are already familiar with artificial neural network. In that, what you do, we give data to a particular model, and from that particular data we find out some outputs. Here also what we are going to do in convolutional neural network, we will provide the particular data in the form of images. We are going to work with images in convolutional neural network. Is it clear? So that's why only that how a person recognizes the images, in the same way we are going to train a particular model which will recognize the particular face in the same way a human recognize the particular things. And we are going to train a model that will predict the particular thing. Like now we are going to predict, like we are seeing a picture, and what we are predicting that this is particular a rabbit or an eagle or a bird, basically we can say. So in this way only we are going to create a model also which will predict these things. Yes. Achha, okay, ma'am. Just 1 minute. Okay. Now what we are going to do, you can see again a particular image. Can you see that particular image? This one. Yes, this one. What you are going to visualize through this image? Can you tell me? It's an illusion. Am I right? Hello?
Yes, ma'am.
Yes, it's an illusion. There is only one face, but it is looking like there are two faces in this particular image. Correct? So these are some of the examples like how a particular human see a particular thing, and how we are going to create a model also, like it will predict the things as we see the particular images. Is it clear? Convolutional neural network is nothing but what we are going to do in this particular thing is we provide some data in the form of images, and that in that particular data what we are going to do, we are going to predict some of the features, and after predicting the features we are going to taking out the output on the basis of these features. Is it clear? Now
Yes.
tell me one thing. If we deal with images, now images are of different types. It is not necessary that all the images are of frontal face only, or a particular good image, or 3D images. You can get blur images also, or we can say blur images or some tilt images and different type of images. Then how our network work with this type of images? What we do is we do some pre-processing steps in which what we are going to do, we perform some of the operations on these images, and that particular step is known as pre-processing. And in that, we particularly what we should do, that we should perform some of the operations on the images, and after that what we do, we provide some of the particularly pooling layers, Relu layers, and taking out the output from this particular things. Is it clear? Any doubts? Do you understand what is the meaning of convolutional neural network now?
Yes, ma'am.
Should I ask some questions? Can you tell me in convolutional neural network which type of data we should provide to our model?
In form of images?
Okay, in form of images. Yes, correct. In convolutional neural network, we are going to provide the data in the form of images only. Okay, fine. After that, again, you can see a particular images. See, left images of cheetah, second one is of a bullet train, and third image. Can you recognize what is this particular thing in the right hand side? Anyone?
It's a magnifying glass like a
It's a
structure.
magnifying glass. Yes, yes, yes. See, but it is not clear that this is a magnifying glass. Is it correct?
Right. Yes,
Yes.
yes.
These two pictures on the left hand side are correct. There's one is cheetah and second is bullet train. But the third image is not properly clear that it is a magnifying glass. So what should we do? That we should train our model in such a way that it predicts all the things properly. It is not necessary that every time our model predicts the particular thing correctly, but means we should train a particular model like that it predicts the things correctly. Is it clear? It happens
Yes,
many times that, like right now, we are not sure that this particular thing is a magnifying glass or something else. So in the same way, our model also sometimes doesn't recognize that is a particular magnifying glass or a something particular another thing. Is it clear?
Yes, ma'am.
What is the convolutional neural network? Artificial neural network. Yes. So yesterday you have a session of artificial neural network in which you learned so many things. You can see here that in artificial neural network and convolution neural network, what is the interest over time? This is a particular graph of past years in which you can see that artificial neural network and convolution neural network graph are basically merging at a particular time. Like in 2020, we can say that these things are going simultaneously. Means the value of both the networks are increasing day by day. Now, these are some of the personalities which are giving their contribution in the field of artificial intelligence, and one is in Google and second is Facebook AI scientist, chief scientist of Facebook, or I should say Meta. Now, what is the structure? Now, you have learned a particular structure of artificial neural network. Can you tell me what is the difference between these two particular architectures? There is any difference? See, here also we are giving a particular input data to our model. We have applied a particular CNN, convolutional neural network, and after that we created an output label. That is what is the class of particular image. Now, what is the difference between ANN and CNN? Both these structures are same, I think, or they are different. Yes, both the structures are same or different. Anyone? Hello. Yes. Can you recognize this particular structure? See, basically the model structures are not so much different. Here only the difference is that we provide the input as an image in particular convolutional neural network. After that, some of the pre-processing steps will come. After that, some convolutional layers, and then we are going to predict the image class. That what is the particular thing we have provided here. Now, what we are going to predict to these things. Like for example, I'll give you a picture of dog. You will instantly recognize that this is a particular dog. But is it possible for a machine to recognize that particular thing instantly? No. So what we are going to do, we are going to create a model that would recognize the classification, like what is the particular image representing you. It is dog or a cat particular. Is it clear? So what we are going to do here, we are going to give here some input images. On these input images, we are going to train our model. And after training our model, we are going to create the output label here that it is a particular dog or a cat. Is it clear? So for these particular purposes, we are going to create convolutional neural network. Till now, any doubts to anyone? Hello?
No, ma'am.
Okay, fine. So now, again, you can see a picture here and there are two pictures. Can you tell me what these pictures represent? Yes, anyone? See, these are two faces. One is happy face and second one is sad face. It is clear? As a human, we have easily recognized these things, that one is happy face, second one is sad face. But does your machine will recognize it easily that this is a particular happy person and this one is sad person? It is not. It is not so much clear for a particular machine to recognize these things easily. So what we are going to do, we are going to give some of the images of happy faces to our machine, some images of sad faces to our machine. After that, we are going to provide a convolutional neural network on these images, and after that, we are going to find out that what a particular face tells, that it is happy face or sad face. But this time, this work will be done by our machine, not by us. Is it clear? So to recognize someone's face, we are going to take help of our machine in this convolutional neural network. For example, okay, fine. From this, tell me one thing. You all use social networking sites. Everyone use. So have you ever seen in Google Photos, it recognizes your photos instantly? As soon as you upload your pictures on that particular Google Photos, it recognizes your pictures. How does it recognize your picture that this person in the picture is you? Can anyone tell this? Everyone has seen this picture.
Yes, ma'am.
So how does it recognize?
Because of CNN.
Yes, because of CNN, it is a particular model running behind that particular thing. What does it do? It is the particular model is trained on thousands of images. It is trained, and after that, when you provide one of your image, it instantly recognizes, yes, this is the particular image of a person. So here also we are going, what we are going to do, we are going to train our model on multiple images, and after training that particular model, it will recognize the particular face. So when we are training the model, how we are going to train a particular model? What do you think? It takes the whole face and recognize it? No. See, if you uh, if you have seen this picture, what it will do, it will select the features, it will extract the particular features from the particular image, and on that features it is going to learn the particular things. Is it clear? Like it will learn that how your particular it is, if the person is smiling, it will recognize that particular smiling face, that yes, this is the particular feature I have to extract from the picture, and then it will learn on this particular picture. Is it clear that how a particular picture is recognized by our convolutional neural network? Anyone? See, I'll tell you the process, that how it recognizes a particular picture and how it provides classification on these pictures also. But this is the overview that how a particular convolutional neural network works. Any doubts to anyone? Okay, now let's move forward. You can see here there are two particular images now here. On the left hand side, okay, now I want to ask you one thing, that what is an image? Can anyone tell me? Have you ever heard name of pixels? Anyone? See, image is nothing but image is made up of multiple pixels basically. So you can see here, it is a particular presentation of an image here in which there are 4 pixels, pixel 1, pixel 2, pixel 3 and pixel 4. It is a 2x2 image. It is a matrix basically. Images are matrix and nothing else. So here you can see this is a 2x2 matrix, and again there is a particular image of 2x2 matrix. But what you can see here is the first one is 2D array and second one is 3D array. In 2D array, what is it represent is, it is a black and white image. Black and white image, can anyone tell me that in black and white image, what are the colors that are presented in the particular pixels? Anyone? See, then I'm just asking the questions. so that you will also know that what you are understanding or not something. A black and white, what a black and white image represents? Only black and white colors, basically. You have seen an RGB image and a black and white image. Have you seen these type of images? Anyone? Okay, what is the difference between a colored image and a black and white image? Hello. I'm just asking that what is the difference between a colored image and a black and white image? In black and white image, there are only two color channels. One is black and one is white. Correct? And in RGB image, there are three color channels, basically red, green, and blue. All the colorful images that you see are made up of these RGB images. They are known as RGB images, and all the black and white images have only two color channels, that is black and white. Is it clear? So what we are going to do, if we provide some of the convolutional operations on black and white image or RGB image, we have to provide the color channel in that particular data, that it is either RGB or black and white. Is it clear? Now you understood the difference between RGB channel and black and white image. Anyone? Now if I ask you that what is the three dimensions that represent in a particular image, then you can tell me that yes, it is a RGB image. Is it clear? Hello. Yes. Is it clear to everyone? Okay. Now let's move forward with this. I told you that in convolutional neural network, we are going to predict some of the things that our particular image represents. So in this particular image, you can see there's a happy face of a person. Is it clear? But this particular thing is not known by our computer, that this is a particular face of a smiling person. Now, how our computer will recognize this image? It is a black and white image. So I told you that it will have black and white colors only two color channel. So what our particular model do? What we are going to do? We are going to fetch the particular features. You can see in the eyes part only black color is there. In the nose part also we have seen a black color, and when if the person is smiling, you can see here the particular black color is there in all the pixels, and on the background it is white color. So what here it is doing is it is particularly recognizing the features of a particular image. Is it clear? Now you can see here in the pixel also only 0 and 1 particular numbers are represented here, because it is a two-dimensional channel. The 0 and 1 are presented on the particular thing where features are extracted. In the background, all the particular the pixels are 0, and on the particular features where features are represented or the features are present, we have given the particular number as 1. You can see here the particular number 1 here. Everyone? Hello? Yes. Do you understood this particular thing, that how a feature is recognized by a convolutional neural network? Yes. Now let's move forward. What we are going to do, this is step 1, step 2, step 3, and step 4. In ANN also, we have seen some of the steps, like what we do after providing data to our model. Here also, there are some steps like convolution, max pooling, flattening, and fully connection layer. These are some of the layers, and after that, we provide our model is created, and then we provide some of the predictions to our model. So let's move to the step 1. For additional readings, there are some of the papers written by the person. If you want to refer this, you can refer this too. Now, what we are going to do, we are going to start the step 1 of the convolutional neural network, that is convolution. So what we are going to do here, we are going to provide some of the things to our input image, and from this particular input image, we are going to detect the features of our image. Now, what are the features of our image? Can anyone tell me? Yes, right now I have given you some of the examples that how do our model fetch fetch the features from a particular image. So now can you tell me that what are the features? What is known as features in a particular image? Yes. What are the features basically? Can anyone tell me? Features किसको बोलता है? Hello. Hello. Am I audible? Hello.
Yes, ma'am.
Sorry for the disturbance. Actually, there was some network issue from my side. So we were on step 1. Yes. Now, can you tell me that what are features? Anyone? So features are nothing but some of the highlights we can say, or we can say the particular thing through which we recognize a particular face. If you take a human face, then what are the features of a particular human face? We can say eyes, nose, lips. These are the features through which our face is recognized. It is clear. So through these features only, our model will also recognize the particular image. So in this particular image, the last image we have taken a smiling face. In this, the features, what we are going to recognize the features, the eyes, in the middle, the nose, and the smiling face. These are the important features through which a particular model will recognize that yes, this the particular face is a smiling face or a happy face, we can say. So what we are going to do, we are going to convert this particular image in a particular small size image, in a small matrix. You can see here that the last one, that input image is of 7 cross 7 matrix. This is a big image, correct? What we are going to do, we are going to extract the important features, the important things from this particular image, and we will create a particular feature detector here. Feature detector is nothing, a 3 cross 3 matrix. You can see here at the right hand side, you can see this is a 3 cross 3 matrix of 0 and 1. Everyone can see what we are going to do. We are going to strike this particular feature detector on the input image, and we will create a particular feature map from this particular image. What is a feature map? Feature map is nothing. We are going to cut short the unnecessary things from the particular image, and we will take up the particular some of the important features of our image. In the next slide, I will show you that what is a feature map. You can see here, see in the input image what we have done. This is a feature detector. From this feature detector, we have done the multiplication of the input image. So what we are going to do, we are going to slide this particular 3 cross 3 window one by one on the whole image, and then we are going to create a feature map here. Feature map is nothing but the important features we have selected from our particular image. Why we are going to select this important features? The important features we are going to select to recognize a particular face, that what this particular image is trying to say us. Is it clear? So after creating this particular whole thing, we have found a particular feature map. You can see here, one by one, the particular window is sliding. Can you see this? The particular window is continuously sliding. and it will create a particular feature map. Now, after sliding this window, what we are going to do, we are going to multiply the particular numbers from each other. We are going to multiply the input image through the feature detector and will create a feature map here. So that what we are going to do, we are going to find out the important features from the image. So you can see the particular multiplication and the particular answers are coming here. Now what does you recognize in the last image? You can see here from the semi-short 7 matrix, we created a short matrix that is of 5 cross 5 matrix. If you give a particular input image to our model, a proper input image, it will give you predictions good on the basis of that. If you provide a very large image or an unambiguous image, you will not get the particular desired output you want from your model. So we have to do the pre-processing steps in our particular data set. After that, you can see here, we have created the feature maps. This is known as feature maps, that when you provide feature detector to our input image, and from that we create a feature map, that is the important features from the image we have fetched are known as feature map. Is it clear? So this particular operation right now, this particular operation which is performed in the input image is known as convolutional. Hello. Again, sorry for the disturbance. There is some network issue from my side. So where we were, yes, we were discussing the particular convolution. Yes. So this operation we have performed on the input image through feature detector after creating a feature map is known as convolution operation. So this is the first step of convolutional neural network. Do you understand this step, that how we perform a feature, how we create a feature map from an input image, and why do we create a feature map first of all? Anyone? I told you what is a feature map. I told you what is an input image and why do we create a feature map from an input image. Anyone? What is a feature map? Right now, I told you all the features that what is it is going to perform, why it is important, then why do we create a feature map from a particular image? Anyone? It is very easy. See, we are going to extract some of the necessary features. See, you can see through the name only it is written here that feature map is nothing. Basically, we are going to create a particular matrix of an pixels that will provide us some necessary information that is going to help us in the near future when we are going to predict something from our model. After that, you can see here we have created so many feature maps, and this is known as convolutional layer. Convolutional layer means that a layer in which there are multiple feature maps are there in a hierarchical order. After that, again, you can see some of the operations we are going to perform on a particular picture. Now, before inserting our data in our model, we have to provide some pre-processing steps. Now, pre-processing steps in a particular data means, like you can see here, an image of, or you can see Taj Mahal here. What we are going to do, we're going to perform some of the operations and we will see that how the operations are performed on this particular image. Now what we have provided here, you can see here, this is a 5 cross 5 matrix on the left hand side. In this particular matrix, all the background we have done is 0 and on the middle of the particular thing is 5. We have provided a particular value 5. What this particular thing represents is if you want to sharpen a particular image. If you want to sharpen a particular image, you have to write this particular thing on this particular image. So you can see here in this particular image, in the middle of the particular thing is highlighted and the background is somewhat blur, we can say. Is it clear? many of the times, if we use some of the applications in our mobile, you can see we have the features like sharp on a particular image. You can increase the contrast of an image. You can make a picture blur. We all have performed such kind of operations. Have you performed this type of operations? But we don't know the particular operation, or we don't know the particular thing that is working in the backend. So these are the operations which are working in the backend in this particular image. If you want to blur a particular image, you have to provide this particular matrix to your image. You can see here. Now you can see the middle part of this particular image is blurred. Is it clear? Again, we will see some operations. C, enhancement. As enhancement means the edges of the particular, you can see here, the edges of the particular image, we have enhanced the edges, and all the particular and the full image is black. Only you can see some of the edges of the particular image. So to provide why we are seeing this? Why? Because when we provide particular data to our model, we have to perform some of the operations so that we can get perfect output from our model. And these steps are known as pre-processing steps. Again, let's move forward. See, edge detect. Now, from this particular convolution, what we have found that if we provide this particular convolution operation to our image, it will detect the edges. Only it will detect the edges. Before that, we have seen to enhance the particular image. Enhance means we can emboss the particular edges only. But here it has detected the images of the particular image. After that, emboss. Embossing means you can see the 3D effect of the particular image. Emboss means it is looking like it is coming out from the particular, the image is coming out from the computer, we can say. It is looking like that. Embossing means the illusion we create through the image, like it will give the 3D effect of your image. So if you want to perform this emboss operation, you can provide this particular convolution on our particular image and create this particular thing. Now, why we are taking this particular 3x3 matrix, 5x5 matrix? Because as we have seen in the last particular example, I told you that it was a 7x7 image of a smiling face, and from that, hello. Hello. Someone is speaking. Hello. Hello. Any doubts to anyone? Shall I continue? Hello.
Yes, ma'am. Yes, ma'am. Continue.
Okay, fine. So you can see the embossing effect of a particular image here. Is it clear? So these are the operations we have to perform to create a particular clean data from our image. Now, see, now you can see what we have done. We have given a particular image here. You can see a left-hand side image. After that, what we have done, we have multiplied this particular image with a feature detector. This is a feature detector. The 3x3 matrix you can see here is a feature detector. And what this particular feature detector is doing, it is creating a feature map here. Is it clear? What it is doing, you can see here, it is showing the necessary features. You can see the hairs of a person, the ears is recognized here, nose and specs is not clearly recognized, but the main features of a particular face is recognized through this particular feature detector. So we apply feature detector to our image to recognize the important features from our image. Is it clear? Now you understood the particular concept, why we use a particular feature detector and why we create a feature map from a particular image. And this particular operation is known as convolution operation. So now you can even create a feature map of your image too. If you are having your image, you can provide this particular feature detector to your image and you can create a feature map of your image. Even you can train a model on your images also that it will detect your face. Now, Relu layer. So do you understand this particular layer, that what is convolutional layer in convolutional neural network? Any doubts till here? See, we have completed the first step of convolutional neural network. After that, we will go to the Relu layer. That how after that, after we have created a feature map. Now, what we are going to do this with this particular data? So till now, any doubts to anyone? See, in day-to-day life, now we are using Android or iOS mobiles. You can see there is a face unlock of a particular feature. It is provided in such kind of mobiles. Then what is the particular functionality they are providing us? It is the AI working behind. It detects the particular features of your face and recognize your face that yes, this is the particular person, and through that, they are going to unlock your mobile. So in day-to-day life example, there are many examples that we are using this convolutional neural network in our day-to-day life, or we can say in the real world. You can also tell some of the examples you have seen of convolutional neural network in your basically into day-to-day life. Anyone? See, we regularly deal with this particular thing nowadays. Through social networking sites, you have seen such kind of things, and many more things. Now, the step second is Relu. So what is the Relu layer? Let's see. From the feature map, we have created the feature map. After creating the feature map, do you think that we can only recognize, or only through the feature map, we can recognize the particular output from our model? No, we have to perform some of the operations also after this creating the particular feature map. So what we are going to do? You can see here on the left hand side, it is our input image. In this particular, after input image, creating an input image, we have provided the convolutional layer. If you have seen, you can see here before I told you when we were creating feature map, there are some of the particular images in which minus values are there. You can see here in the particular image, there are some of the values that are negative values, we can say. So what we are going to do, we are going to remove this particular negative values from our image. So how we can remove the negative values? We are going to perform the Relu operation. Relu operation is nothing, but it is a particular operation which what it is going to do, it will remove the negative values from our model and it will only provide the positive values to our image. Is it clear? So what we will do, we are going to particular write a operation, or we will say we will provide a particular function here. In that function, what we will do, the particular function will this particular function will provide the feature that it will remove the negative values, it will round off the negative values to 0. And it will only have the particular image. The particular image will have only positive values, because in a particular image there is no negative value. We will round off these values to 0 and then it will convert the particular thing to 0. Is it clear? So this is the main reason that why we use Relu layer after convolution layer, because in the feature map you have seen there are some of the negative values in that particular feature map. So we will remove the negative values from the feature map with the help of Relu function, and we will not remove the particular value. We are going to round off the particular value with the help of 0. Is it clear? So this was the functionality of the Relu layer, and this is the graph of the particular Relu layer. See, we will see an example that how this operation is performed. You can see a picture here. After that, what we are going to do, we are going to perform Relu operation in this particular picture. See, you can see here that black represents the negative and white represents the positive value. If there is some negative value in your particular image, it represents the black area of the particular image, and white represents the positive values. So what we are going to do, we have to remove the basically negative values, means the black part of the image from our picture. So what we will do, we will see that this, you can see this particular picture. Now from where you can see that there are some black part of the image, you can see in the middle and on the right hand side, you can see some of the negative values, or we can say the black part of the image is there. So in the next image, you will see that we have removed this particular thing. You can see here. Now you can see only the non-negative values. Non-negative values means positive values. So through Relu operation, what we have done, we have performed that we will remove all the non-negative values with 0 and we will create this particular picture. Is it clear? Is it clear to everyone that what we have, why we have performed this particular operation? Anyone? Any doubts to anyone? Hello? Okay. Now, after providing this, this is the additional reading if you want to refer some of the things for understanding convolutional neural network. Yes. So this is the Relu operation. Now we are going to provide the max pooling function. Till now you understood the convolutional operation and Relu operation. Now we will summarize some of the things we have learned till now. Can anyone tell me that what is convolution operation we perform on a particular image? Anyone? What is the convolution operation? Right now, I told you that what is this operation, why we perform this operation and how it is performed. So can anyone explain this particular thing in a summarized way? Anyone? Any doubts to anyone? If you're not, okay, fine, I'll tell you. See, what we have seen a particular image. From that image, we want to predict some of the things. So what we have done, we have provided the image to a particular model. Now, how that particular model will perform? First of all, the model will take the image. It will see the number of pixels in the particular image and what is the size of that particular image. The size of our image was 7x7 matrix and it was a smiling face. Is it clear? Now what we have done, we have, yes. Hello. Someone was saying something. Should I continue? Hello. Okay. So where are we? Yes, we have taken a particular input image. From that input image, what we have done, we have first of all, we have performed a convolution operation. So in that convolution operation, what we have done, we have selected some of the important features from that particular image. Now, after selecting the important features, we have seen that in our feature map, there are some of the negative values. In a particular image, we should not take some of the negative values. We should remove the particular negative values from the images because they are unnecessary numbers that are there in our images. So remove the particular negative values, or we can say we want only non-negative values in our particular image. We have performed the Relu operation. So after performing the Relu operation, we have seen that we have created a particular feature map of only positive numbers. After that, what we are going to do, we are going to perform the max pooling operation. The convolutional neural network is divided into these 3 to 4 layers, we can say, and all the layers are interconnected to each other. So after that, after we have performed the Relu operation, we are going to perform max pooling operation. You will also understood that why we are going to perform max pooling operation here. So again, you can see this is an image. This is the feature map we have created. All the places where negative values are there, we have replaced it with 0. Now we have a feature map with only positive values. After that, what we are going to do, we are going to perform max pooling operation. In this max pooling operation, what we are going to do, we are going to find out the maximum value from the particular image. The maximum value represents the most important feature of our particular image or a picture. So how we are going to perform it? Again, what we are going to do, we are going to take a 3x3 matrix here. We are going to perform a particular stride operation and we will slide the window to whole image in the particular operation. So you can see here, again, you can see this is the feature map we have created through feature detector in our convolution operation. Through this feature map, we are going to provide the max pooling operation to this particular image. Now, after providing the max pooling operation to the particular image, what we are going to find out is pooled feature map. The output will be pooled feature map. First, we find out the feature map. Now, what we are going to find out is pooled feature map. So, you can see here, you can see here we have taken a 2 cross 2 matrix. In this particular 2 cross 2 matrix, we are going to start it from the left hand side of our image. So from left hand side of the image, you can see from this 2 cross 2 matrix, the highest number is 1. Am I correct? So we are going to take the highest number and we are going to place it in this particular pooled feature map. After that, again, we are going to slide this window. After sliding this window, again, it will come 1 or 2. Let's see. You can see here, yes. After sliding the window, the max value is again 1. Can you tell me, again, if I will slide this particular window, what I will get the output here? Anyone? I will slide this window again, one stride. Then what I will get the output here in the third block? What will be the maximum value I will get here in this particular third block? Anyone? See what we are doing. We are going to slide this window one by one and we are going to fetch out the maximum value that is there in this particular picture. So in the left hand side, when we are performing operation here, we can see here that from 0 and 1, obviously 1 is the greatest number. So we are going to provide the particular number here. After that, again, we have slide the particular window and what you will find that you can see here, this is the 1 here. Again, we are going to slide this window once again and you can see the maximum value will be obviously 0. You can see here because only 2 values are there and on both the values are 0. So maximum value is again 0 here. On the right hand side, there is no particular thing. So we are not going to recognize it. We will take only this particular 2 zeros. Let's move forward. The whole image. In the whole image, again, we will see on the left hand side, if we will scroll down, it will take the maximum pooling layer, will take the particular maximum number will be 4. You can see here, we are going to provide, you can see, again, you can see here that the maximum number is 1, 0, 4 and 1. So the largest number will be from 4 from all the 4 numbers, correct? Again, if we are going to stride this particular window 1, it will get the particular number 2 as the largest value. Is it clear? You can see that how max pooling operation is performing. You can see here. We are just finding out the maximum value from the particular window and nothing else. So can anyone tell me if I will slide again one window on the right, what I will get the particular number here? What will be the maximum value I will get here after 4, 2 and anyone? No. Can you tell me what will be the maximum value? Anyone? See, it is very simple. The maximum value will be 1 because from 0 and 1, the largest value will be 1. You can see here. We are just going to find out the particular maximum, or we can say the largest value from the whole window. Whole window means we are going to perform the operation of 2 cross 2 matrix, means from the 2 cross 2 window, we are going to find out the maximum or the largest value from this particular window. So you can see here that in this particular window, only 2 values are there, 1 and 0. So from 1 and 0, the largest value is 1. So we are going to place it here in the feature map. Again, we will scroll down this particular window and we will find out the last 3 values that are going to be here in the pooled feature map. That will be, I think, 0, 2 and 1. Yes, you can see here 0, 2 and 1. So is it clear the max pool operation? That how we have performed this particular max pool operation on an input image? It is clear to everyone. This why do we provide this operation? You can see here we have started with an input image of 7 cross 7 matrix and we have created a 3 cross 3 matrix from that particular image. Means we have reduced the size of that particular image. If you will give a particular image of big size to particular model, it will take time for it to recognize the features from that particular image. But if you will provide a proper image to your model, it will instantly, or it will take very less time to recognize the things, because all the features are already there in this particular feature map. It will not take time to recognize such kind of things. What we have done, we have taken the particular things that are very important for a particular image, and we have removed the unnecessary things from our particular image. And you can see here, we have cut short the image from 7x7 matrix to 3x3 matrix by performing 2 to 3 operations on the particular input image. Now, do you have any doubts till here? Anyone? Should I continue? Hello. Do you understood that how we have created this pooled feature map on the right hand side of the window? How we have performed this operation? It is very simple. We have taken a 2x2 matrix, and it depends on you. You can take 3x3 matrix, 2x2 matrix, but if you are taking a 5x5 input image, you can see here on the left hand side we have seen a 5x5 matrix. So take a particular feature map that is reliable for our input image. Okay, so I thought that 2x2 matrix is good for a particular image. So I have taken the particular matrix, and then what we have performed? We have performed max pooling operation. Max pooling operation is nothing. It will select the maximum value, or we can say the largest value from that particular window, and it will place it in the particular pooled feature map, so that we can create a particular feature map that will have the maximum or the largest value, that is the particular most important features from our particular input image, that will help in our predictions. This will help us to predict the particular input image correctly. It is clear to everyone? See, I told you at the beginning that we are going to perform this particular convolutional operation in 4 to 5 steps. The first step was convolutional operation we have performed. After that, we have performed the Relu layer. After that, the max pooling operation. And after max pooling operation, we are going to perform the fully connected layer, or the particular dense layer we are going to add in this particular model. Now you can see here, this is the architecture. This is an input image in the left hand side. After that, we have performed the convolutional layer. So you can see the convolutional layers, multiple convolutional layers of our input image. After that, we have performed the pooling. You can see the particular image, the size of the image is reducing as per the operations. First of all, the image was of 7x7 matrix. After that, we have created a feature map, that is the convolution operation of 5x5 matrix. And after that, we have created a pooled feature map that is of 3x3 matrix. So you can see here that how easily we have reduced the input image, the size of the input image. Any doubts to anyone? Now, the step 3 is flattening. Now, what we are going to do? Flattening means that we are going to particular convert this 2x2 matrix in a one-dimensional array. Can anyone tell me that what is a one-dimensional array? Yes. Anyone?
Single row?
Single
Yes,
row.
ma'am.
Yes,
Single
correct,
row.
correct. Yes, correct. So what we are going to do? We are going to convert this particular 2x2 matrix, that is the two-dimensional data, into one-dimensional data. We are going to change the dimension of this particular data. Why? Because we are going to find out the predictions through this particular feature map. So what we are going to do? We are going to provide the particular data to our fully connected layer. Can someone tell me what is fully connected layer? In artificial neural network also, you have studied about fully connected layers. Anyone? Dense layer. Have you heard this particular names? What are dense layers? What are fully connected layers?
No, ma'am.
Okay, fine. I'll tell you. See, what we are going to do, we will provide this particular data to fully connected layers. Fully connected layers are nothing but there are multiple neurons in a particular convolutional neural networks. So all the neurons will be connected to each other, and that is known as fully connected layer. In fully connected layer, you cannot provide a particular data in the form of 2D or 3D array. In fully connected layer, you have to provide the data into one-dimensional array only. That is flattened data. Is it clear? So you can see here we have done the flattening. You can see the one-dimensional array here, 1, 1, 0, 4. All the data is in one dimension now. Is it clear? So
Yes,
after
ma'am.
flattening the data, we are going to provide this to fully connected layer. You can see here, there are multiple neurons here. Can you see the multiple neurons here? Number of neurons. What does these neurons do? These neurons are going to predict the particular thing, that what your image performs, what your image is performing there. Is it clear? So after that, you can see the full connection. See, after flattening, I told you that this will be the fully connection layer. You can see the flattening layer. After performing the operation of flattening, we have flattened the data into one dimension, and we have provided the data x1, x2, x3 with the number of till the number in your particular input layer. So how many number we are having here? You can see here 1, 2, 3, 4, 5, 6, 7, 8. It was 3 cross 3 matrix. Our fully connected layer will be having 9 elements, we can say. So you will see here we will have x1 to x9. Correct? Is it correct? After that, we are going to create a basically connection, where we are going to say that we are going to create a network here. What this network will do, we are going to perform a prediction here, that what our model will predict. So we will create multiple neurons will be connected to each other. You can see here there are a number of neurons that are connected to each other. We can see a particular architecture of we can say an architecture in which all the particular nodes are connected to each other. You can see here. So after this, what we are going to do, we are going to connect each of the node with each other, and particular each node will perform any one operation. You can see here that after that, what we have done, you can see here that y and y dash. You can see here there are two outputs after providing the fully connected layer to the model. So what this output represents, the one output will represent that the particular person or the particular face is happy face, and second one will recognize that the particular face was not happy. Is it clear? See, every prediction will have two particular, we can say hypothesis, or we can say whenever you predict something, there is a probability of a particular thing. So here also there is the probability that the person is happy, or the particular face is happy face, or the particular face is not a happy face. Happy or sad, we can say. Is it clear? Is it clear to everyone? So the last
Yes.
output value will be the particular face will be happy or sad.
Sad.
Okay. Same for dog and cat also, as in the previous slide, I told you that we can recognize the particular input image also. If you give an input image of a particular dog here, through the particular all the operations, and after performing the fully connection layer, you will get the output like the particular picture is of dog or of cat. Now, how will you recognize this particular thing? See, you can see here. See here. You can see here in the last particular layer, there are some of the numbers written here, 0.91, 0.2. This is the probability that what your model has predicted. So you can see here the model has predicted that particular neuron 0.9 is going to dog. One particular 100% probability is for dog, means basically the number of neurons which are given here, and what is the probability it is giving here, that the particular input image is of dog or of cat. So you can see here the most of the numbers are representing the basically that for this particular neuron represents that it is a dog. So from this particular thing we understood that yes, how it is performed, that how we are going to predict a particular thing from our convolutional neural network. Is it clear to everyone? See, this is the operation we are going to provide in artificial neural network also. These are the layers you can see here in the ANN also. In the previous session, you have studied ANN, so you have seen that these are some of the layers which are interconnected to each other, and through which we are going to find out the predictions from our model. It is clear to everyone? See, you can see here the nodes it represents. It is not written the value. The values are not written here, but at the back end, each and every neuron is particularly provided a particular value. Each neuron is given a particular value. On the basis of that particular value, it is predicted that either it is the dog or a cat. It is clear to everyone. You can see here. To understand it well, you can see the number of values here and what are the number of values provided. Obviously, if a particular value is taking high weightage or a particular neuron is having high weightage, it will give the better predictions. Yes, you can see here this. We have provided the input image. We have provided all the layers, that is convolutional neural layers, a Relu layer, and flattening. After flattening, we have created a fully connected layer, and through we have predicted that a particular image is of dog or cat. You can see here, see. Now, the predictions are giving the output here, like the dog is 0.95 and cat is 0.05. Is it clear?
Yes.
Is it clear? Means
Yes,
from this particular thing, you can understood that the predictions are that obviously if a particular thing is 0.95, 0.95 means 95% probability is of dog and 5% probability of cat. Means our model has predicted that 95% probability is this a particular image is of dog, but only 5% probability is that it is a cat. But what we are going to do? We are going to go with this 95% probability. Is clear?
Yes,
It is clear to everyone? Okay. So you can see here. See, now for cat, if you take a picture of a cat, now you can see the probability of dog is reduced and the probability of cat is 0.79%. So based on this probability, we are going to predict that, yes, the image we have provided is of which category. Is it clear? You can category multiple images also. Right now we have taken only binary classification. Binary classifications means what? That either it is a image of dog or a cat. Means we are going to predict the things in our binary classification is either it will be 0 or 1. 0 or 1 means it will only predict only one thing. But you can make it through just 1 minute. You can make it through multiclass classification also. If you are giving pictures of, let's say, 10 different flowers to our model, it will recognize the probability of each and every flower. Like it is given here that the probability of dog is 0.21 and cat is 0.79. Is it clear to everyone that how convolutional neural network works? Yes.
Yes, ma'am.
That is clear to everyone. Now, should I ask some questions or do you have any doubts? I'll summarize this
ma'am.
particular whole thing. Yes, sir.
मैम तो जो नंबर ऑफ न्यूरॉन्स है या फिर लेयर्स हैं तो हम ये कंक्लूड कर सकते हैं लाइक ज्यादा लेयर्स रखेंगे तो वो ज्यादा अच्छे से मतलब और डेटा मिलेगा उसे और अच्छे से वो बता सकेगा डिफरेंशिएट कर सकेगा इज इट डॉग और कैट
नो इट डिपेंड्स अगर आपका पर्टिकुलर आपने डेटा लिया है जिसमें मिलियंस ऑफ इमेजेस हैं, अगर आपके पास बहुत सारा डेटा है तो आप उसमें मल्टीपल न्यूरॉन्स उसमें बहुत सारा न्यूरॉन्स लगा सकते हैं. बट अगर आपके पास डेटा बहुत कम है, लेट्स से कि आपके पास सिर्फ 100 इमेजेस है और आप उस पर बहुत कॉम्प्लेक्स मॉडल लगा देंगे तो फिर आपका मॉडल जो है या तो वो ट्रेन ही नहीं होगा या फिर वो बहुत ज्यादा ट्रेन हो जाएगा. सो इट डिपेंड्स ऑन द डेटा. मीन्स आपको वो डेटा पे डिपेंड करता है. अगर आपके पास डेटा है बहुत सफिशिएंट डेटा, देन यू कैन क्रिएट अ कॉम्प्लेक्स मॉडल. इट विल डेफिनेटली वर्क वेल फॉर योर मॉडल. बट अगर आपके पास डेटा कम है सो यू हैव टू क्रिएट, या तो आपको डेटा उससे बनाना पड़ेगा, और अगर आपके पास डेटा कम है तो देन यू हैव टू गो फॉर अ सिंपल मॉडल लाइक जिसमें थोड़े कम न्यूरॉन्स हो. ओके, एनी क्वेश्चंस, एनी मोर क्वेश्चंस, एनीवन? Hello. Yes, any questions? See, this is a real world application you can see here. हम रियल वर्ल्ड में ये सारी चीजें डे टू डे लाइफ में देख रहे हैं आज के टाइम पे। आप सबने फेसबुक यूज किया है, यू ऑल यूज फेसबुक, हम सब फेसबुक यूज करते हैं। उसमें इफ यू अपलोड योर पिक्चर, अगर आप अपना कोई पिक्चर अपलोड करते हैं, देन इट आइडेंटिफाइज यू, वो आपको आइडेंटिफाई करता है दैट यस यू आर द पर्टिकुलर पर्सन एंड इट टेल्स योर नेम टू देयर। या फिर आप पर्टिकुलर, इफ यू हैव सीन, आपने देखा होगा कभी कि आप अगर एक ग्रुप फोटो अपलोड करते हैं, सो इट विल रिकॉग्नाइज योर फ्रेंड्स टू, वो आपके फ्रेंड्स की भी नेम बताता है। It recognize the pictures. Am I correct?
Yeah, while tagging.
Yes,
Yes.
yes, while tagging, yes. So what is the feature? It is the artificial intelligence working behind that. वो artificial intelligence है जो पीछे से वर्क कर रहा है। हमने पर्टिकुलर, फेसबुक ने ऐसे पर्टिकुलरली मिलियंस ऑफ डेटा पे अपने मॉडल को ट्रेन किया है कि जैसे कि आप पर्टिकुलर अपना क्या देते हो, पिक्चर उसको प्रोवाइड करते हो, इट विल इंस्टेंटली रिकॉग्नाइज, वो इंस्टेंटली रिकॉग्नाइज कर लेता है कि यस दिस इज द पर्टिकुलर पर्सन। And it is not necessary, ऐसा जरूरी नहीं है, if a picture is blur or if two persons are looking similar, then it recognize the both the person same also। वो कभी कभार ये चीज भी होती है। So model is not 100% correct, every time the model is not 100% correct, but a model which gives you accuracy of 90 to 95% is recognized। अगर आपको कोई मॉडल जो है जो 90-95% accuracy दे रहा है, then we go with that particular model, because it will give the particular prediction of 90 to 95%, and 90 to 95% is a good accuracy from my point of view, so we go with that particular prediction। There are many more examples we use a convolutional neural network in our day life, not this only। Can anyone tell me from your side, आप बता सकते हैं that what you have seen such kind of things? See, in each and every social networking site nowadays you can see this particular functionality। आपको ये functionality हर एक particular social networking site पे मिलेगी। And nowadays each and everything is going behind artificial intelligence। You can see each and everything are under this particular concern only, that they are making something like predicting। Yes, you can see surveillance system। आपने सर्वेलेंस सिस्टम देखा होगा। सर्वेलेंस सिस्टम इज नथिंग, इट रिकॉग्नाइज योर फेस एज सून एज यू कम इन फ्रंट ऑफ द कैमरा। सो व्हाट इज दैट कि the particular artificial intelligence model is working behind that particular hardware, and what it is recognizing, it is recognizing your face। वो आपका face recognize कर रहा है, and after recognizing your face it is going to ring an alarm, or it will take that particular data into their database। So these are some of the functionalities, or we can say the applications in the real world of a convolutional neural network। The functionality of convolutional neural network is that only that it is performed only on images। आप convolutional network सिर्फ particular images पर ही लगा सकते हैं। It is any kind of image, वो कोई भी तरह की इमेज चलेगी। It is not necessary कि वो कलरफुल इमेज होनी चाहिए या ब्लैक एंड व्हाइट इमेज होनी चाहिए, but it should be a image, means that it should be a matrix। वो एक मैट्रिक्स होना चाहिए, because image is nothing but a, if you see an image, अगर आप image देखते हैं, then it is made up of matrix only। So अगर आप particularly convolutional neural network में we are going to provide a data, it is something matrix only। It is not necessary that it should be of a particular shape also, it can be of any shape। The shape of the input image doesn't matter in convolutional neural network। Why it does not okay, I have a question for you, can someone tell me, मुझे कोई बता सकता है चीज that why कि इमेज का साइज और शेप यहाँ पर मैटर क्यों नहीं करता है? Anyone? अगर आप डिफरेंट टाइप ऑफ इमेजेस मुझे लाके देंगे, अगर आप डिफरेंट काइंड ऑफ इमेजेस लाके देंगे जिसका डिफरेंट साइज ऑफ शेप है, तो मुझे उससे फर्क नहीं पड़ेगा। Why so? अगर डिफरेंट साइज ऑफ इमेज है तो मेरा फीचर मैप भी गलत बनना चाहिए। Am I correct? अगर आप मुझे डिफरेंट साइज ऑफ इमेजेस लाके देंगे, लाइक 3x3 मैट्रिक्स का कोई इमेज है, कोई 5x5 का है, कोई 7x7 का है, बिकॉज ऑफ दिस रीजन ओनली, बिकॉज जब हम रियल वर्ल्ड से डेटा कलेक्ट करने जाते हैं, इट इज नॉट नेसेसरी कि आपको जो पूरा डेटा मिल रहा है वो क्या हो, प्रॉपर हो या क्लीन डेटा हो। So to clean this particular data, we perform the operations. We perform some of the operations. So first of the operation is convolution operation. That's why only we perform the convolution operation, that we create a particular feature map. We create a particular feature map, and when we create that particular feature map is of only one size, that it will be a 5x5 matrix or 3x3 matrix. So from that, what we do, we are going to scale our particular data. We are going to normalize the data, and what we are doing, we are creating a particular data of, we are creating a systematic data from that particular data set. Because if you provide unambiguous data, obviously, let's take a real world example. अगर मैं आपको पर्टिकुलर कोई बुक दूं जिसमें प्रॉपरली पेजेस नहीं है, या फिर आई शुड से कि जिसमें कोई पेजेस बड़े हैं या छोटे हैं, देन इट इज नॉट पॉसिबल फॉर यू टू लर्न प्रॉपरली. इट इज करेक्ट. अगर मैं आपको एक बुक दो, दैट इज एक बुक दो जिसमें पर्टिकुलरली क्या है, ऑल द पेजेस आर प्रॉपरली सिस्टमेटिकली सबमिटेड, जो सिस्टमेटिकली जिसमें जमे हुए हैं सारे पेजेस, then it will be beneficial for you to learn that thing easily. Correct? So this is only the particular thing with convolutional neural network also. If you will provide a perfect or a good data, or we can say a clean data, it will learn easily and it will predict, it will give you a good prediction. But it will, if you will give an unambiguous data or an unclean data, then it will be difficult for your model also to learn properly. So that's why we perform some of the pre-processing steps in convolutional neural network also. It is not only in convolutional neural network. Whenever you create a model, जब भी आप कोई मॉडल बनाते हैं, either it is an artificial neural network, a convolutional neural network, or an recurrent neural network. Whenever you create a model, you have to create a particular clean data set for that. Why do we create a clean data set? For better prediction. It is obvious in day-to-day life only, or you can take example of yourself also. If I will give you a particular proper information of something, then you will recognize it easily. But if I will give you an information that is not clear or unambiguous or unreliable, that it will be difficult for you also to recognize the things correctly. So now this is a machine. Even humans can't recognize the things properly, then how machine will recognize a thing if you're not providing it data correctly? So that is the reason, the main reason, that why you have to provide a particular clean and ambiguous data to your machine. Is it clear? Most of the time this question arises that we are dealing with a machine, हम एक machine के साथ deal कर रहे हैं, then why do we provide correct data to it? Don't take it as machine. The machine is working same as our human brain. वो सिर्फ हमारे brain की तरह work कर रही है. So जिस तरह से हम लोगों को पर्टिकुलर करेक्ट चीजें चाहिए, अगर हमको कुछ रिकॉग्नाइज करना है, तो मशीन विल आल्सो नीड करेक्ट थिंग्स, बिकॉज मशीन टू लर्न्स. मशीन को हम सिखा रहे हैं यहाँ पे. दिस पर्टिकुलर कंसेप्ट कम्स, ये जो पर्टिकुलर आर्टिफिशियल इंटेलिजेंस एंड डीप लर्निंग का कॉन्सेप्ट है, मशीन लर्निंग के अंडर आता है. द हायरार्की यू हैव सीन. So we are going to train our machine. So अगर आपको किसी चीज को ट्रेन करना है, then you have to give a particular complete and systematic data. Until and unless you will not provide systematic things to your machine will not provide good predictions to you. So it is directly proportional to each other, you can say. Is it clear to everyone? And after providing data, some of the operations, we have to perform some of the operations. Some of the operations, like अगर आपकी image बहुत बड़ी है, then it is not possible for a machine also to train on this particular image. आपका data बहुत ज्यादा क्या हो जाएगा, कॉम्प्लेक्स हो जाएगा. So what we are doing, हम पर्टिकुलर उस चीज को थोड़ा सिंपल फॉर्म में लेके आ रहे हैं. व्हाट वी आर डूइंग, उसके ऊपर हमने कन्वोल्यूशनल लेयर लगाई. कन्वोल्यूशनल लेयर क्या करेगी, उसमें से फीचर मैप निकालेगी. फीचर मैप क्यों निकालना है हमको, बिकॉज हम उसमें से इंपॉर्टेंट फीचर्स रिकॉग्नाइज कर रहे हैं. लाइक अभी आपको ये एक डॉग की इमेज दिख रही है. अब इसका जो पीछे का बैकग्राउंड है, यू कैन सी द बैकग्राउंड देयर इज ऑफ ग्रीन कलर. इट इज अननेसेसरी, मुझे उसका कोई काम नहीं है. व्हाट आई विल डू कि मैं इसको इमेज को छोटी करके सिर्फ इसका फेस पर्टिकुलरली क्रॉप करूंगी. I'll do that. After cropping the particular face, अब मुझे इसमें ये दिख रहा है कि मुझे पूरा फेस रिकॉग्नाइज करने की जरूरत नहीं है. What I will do, मैं इसकी जो आईज हैं, जो नोज हैं, और जो पर्टिकुलरली लिप्स, जो माउथ का फेस है, वो हम क्या करेंगे, पर्टिकुलरली एक्सट्रैक्ट कर लेंगे. एंड आफ्टर एक्सट्रैक्टिंग दैट, उसको एक्सट्रैक्ट करने के बाद व्हाट वी आर गोइंग टू डू, वी आर गोइंग टू ट्रेन आवर मशीन ऑन दिस फीचर्स. इज इट क्लियर? अगर आपको ये पर्टिकुलरली चीज हमको रिकॉग्नाइज करने की फीचर्स पे कैसे ट्रेन होता है मॉडल, अगेन आई हैव एन एग्जांपल फॉर यू. अगेन द एग्जांपल ऑफ गूगल फोटोज. एवरीवन यूज गूगल फोटोज. nowadays, है ना? So in Google Photos, if you have a sibling or your mother, father, and if you recognize, अगर आप अपने मम्मा पापा या फिर अपने siblings जैसे दिखते हैं, होता है ये particularly features अपने आते हैं. So आपने कभी नोटिस किया होगा कि जो Google Photos है वो उनको भी recognize करता है आपके फोटोज में. हुआ है किसी के साथ ये? Anyone? गूगल फोटोज जो है वो रिकॉग्नाइज करते हैं. अगर आपके सिबलिंग्स हैं तो उसमें आपकी फोटोज को भी रिकॉग्नाइज करेगा.
यस
दिस
मैम.
हैपेंस. ये कभी ट्राई करना, ये इसको रिकॉग्नाइज करता है. तो वो क्या करता है, वो आपके फीचर्स एक्सट्रैक्ट करता है. आपका पूरा फेस लर्न नहीं करता है, फेस पर ट्रेन नहीं होता है. इट इज ट्रेन ऑन योर फीचर्स. कि अगर आपके आंखें हैं जो उस पर ट्रेन होगा, आपकी नोज है उस पर ट्रेन होगा. सो इट इज ट्रेन ऑन द फीचर्स. तो अगर फीचर्स आपके किसी से मिल रहे हैं, वी कैन से कि अगर आपके फीचर्स जो है वो एक जैसे हैं, देन इट विल रिकॉग्नाइज यू एज द सेम पर्सन. इज इट क्लियर?
Yes, ma'am. And apart from people's, Google Photo also shows about the things and animals.
Yes, it shows. Why?
Yes, ma'am.
Because the model is trained on the features. It is never trained on a
Yes, ma'am.
particular whole image. We can't train a particular model on image. What it do, it splits the particular image in multiple features. The feature map we are creating here, I told you that from convolution layer we are creating a feature map. So this is the feature map which are extracting the features from the image. And after extracting the features from the image, what we are going to do, we are going to give the features to this particular layers. These the neurons you can see here, multiple neurons which are interconnected to each other. And after performing this particular operation, you can see the output of the particular thing. That either it is a dog or a cat. Or if you are predicting a person, so you will predict that either the person is smiling, or the person is happy or sad. It depends on us. So these are some of the things we have seen in convolutional neural network. Now you have understood the concept of convolutional neural network. See, when we read the concept, जब भी हम एक concept पढ़ते हैं, like you have understood this particular concept, do one thing that connected to the real world. आप उसको real world से connect करके देखो. Because AI is nothing but it is coming in, basically we can say that in day-to-day life only we are using AI regularly. We are not doing that, but we are using this particular technology, or we can say with this particular concept in our day-to-day life. We are using that, but we are not knowing that how we are using that. Right now, I told you about the Google Photos, that Facebook again, and some of the features of Instagram also are based on ANN, CNN only. So these are things. Again, if you have heard about Alexa, everyone had. So what is
Yes,
that
ma'am.
particular thing? Alexa is nothing. A particular model is trained on multiple input. बहुत सारे इनपुट पे. इन दैट पर्टिकुलर इनपुट, वो इनपुट जो है वो बेसिकली क्या होता है, वो ऑडियो होता है. एंड ऑडियो इज कन्वर्टेड टू द टेक्स्ट फॉर्म. वो टेक्स्ट फॉर्म में कन्वर्ट करके उसको हम ट्रेन करते हैं मिलियंस ऑफ टेक्स्ट पे, एंड आफ्टर दैट इट इज गोइंग टू गिव यू आउटपुट. बट द वन थिंग इज दैट इज द डेटा वी आर गोइंग टू टेक इज इन द, इट इज मिलियंस, और वी कैन से मोर देन दैट. इतना ज्यादा डेटा होता है जिसमें हमारा मॉडल ट्रेन होता है. So it is nothing but a particular network that is running behind that particular technology. So in each ever you have seen the automation. Now you can see the smart bulbs also. Everyone has seen. Somebody देखे होंगे smart bulbs आते हैं आजकल. So what are they performing the functionality? वो functionality क्या perform कर रहे हैं? They are nothing. Back in that backend only the artificial neural network is working. उनके backend में भी एक ANN work कर रहा है. जिसमें क्या है कि particularly if I say कि particularly change the light or on the particular light, they understood the particular thing and give you the output. And not necessary. हमेशा if you remember, अगर किसी ने try किया हो Alexa, हमेशा जो है it is not necessary कि वो आपको correct predictions दे.
Yes, ma'am.
Anyone has tried? हाँ, हमेशा correct predictions नहीं देती, because it is a model running behind. उसको भी हमने train किया है. इट इज नॉट नेसेसरी कि हमेशा जो पर्टिकुलर आपकी मशीन है वो आपको 100% प्रेडिक्शंस दे. बिकॉज इवन अ ह्यूमन बीइंग, अगर ह्यूमन बीइंग को भी हम ट्रेन करेंगे, लाइक अगर हमारा पर्टिकुलरली फॉर एग्जांपल अगर किसी का कॉलेज एग्जाम है, अगर हम सिलेबस हमारे पास है, उसमें से आप उसमें से बेसिकली ट्रेन हो भी जाते हो, देन टू यू डू नॉट परफॉर्म 100% इन आवर एग्जाम्स. आप 100% prediction नहीं ला पाते हो, we don't give 100% results, then how can we expect from a machine to give us 100% prediction? Is it clear? So then to a machine provide you 99.5% prediction, but ऐसी कोई machine नहीं जो आपको 100% predictions देती है. Is it clear to everyone? Because it is same as human brain. How a brain is working, same as the machine is working. So our brain can recognize things from 25 years back. आपका particular brain जो है वो बहुत सारी चीजें recognize कर लेता है. This is the only reason that why a neural network is based on the architecture of our human brain. Human brain की architecture पे इसको क्यों बनाया है? This is the only reason. Because yes, obviously we can recognize a thing of 25 or 50 years back. Then it is a vast data we are having in our mind. So why don't we create a particular architecture through machines and make them learn so they can also recognize some of the things like that? Is it clear? You have seen some of the robots nowadays, they are coming with artificial intelligence embedded in that. So they can talk with you, they can perform actions and many more things. So this is the particular thing that is integrated behind the hardware. Any doubts to anyone in convolutional neural network? Now you have understood that how this particular functionality is performed on the images. Tomorrow what we are going to do, we are going to implement this thing. Today we have seen the architecture, the theoretical concepts of convolutional neural network, but tomorrow what we are going to do, we are going to perform the implementation, that how it is working behind. We can see the code, हम code देख सकते हैं कि particularly ये work कैसे करता है. So tomorrow we are going to perform the classification. We are going to take a classification problem, and classification problem लेंगे of a leaf classification. Of a tomato leaf, what we are going to do, we are going to take a tomato leaf, हम tomato leaf लेंगे, and we are going to recognize that this particular leaf is infected or not. So through our model we are going by seeing itself, मतलब हम देख के तो हम बता सकते हैं, human can recognize that yes, it is an infected leaf or a good leaf, but how our machine will predict on that, we will see through our model. Is that clear? So any doubts till now to anyone? You can ask me. Anyone? Have you understood the concept of convolutional neural network?
Yes, ma'am.
It is easy. It is not so much tough. It is take it as a normal particular concept we use in day-to-day life. अगर आप उसको एक normal concept की तरह लेंगे, तो you will recognize it easily. आप उसको easily recognize कर लेंगे. Don't go to this architecture. उसका architecture में मत जाइए. Architecture, if you will see your brain, you will not recognize कि क्या हो रहा है. आप नहीं समझ पाएंगे because it is so much complex. So don't see the architecture. Just only recognize the particular concept behind that. कि उसके पीछे concept क्या चल रहा है. Is it clear? Now you understood the layers. Again, I am going to summarize, make by summarize कर देती हूँ what we have learned today. See, we have started from convolutional neural networks. After that, what we have seen what is convolutional neural network, what is the convolutional operation, Relu layer, pooling, flattening, fully connection, and summary. This extra is softmax. We are going to learn it tomorrow. Okay, so someone is speaking. Hello. Hello. Nikhil Sharma, can you please off your mic? Hello. Hello. Thank you. So, where were we? We are going to summarize the things. So, what we have seen some of the images and we have seen the visualization power. हमने खुद का देखा कि हमारा visualization कैसा है. We have seen some kind of images that are representing two things. Okay, so it takes time, but we have recognized things. After that, we have seen that what is the graph representing ANN and CNN, that how speedily CNN has covered the path with ANN. After that, some of the personalities that are ruling these things. Then convolutional neural network. How does it work? How does it work? Basically, first of all, we have seen the images, that what is images and how an image is made up of. Images are made up of pixels and nothing else. We have seen two kinds of images, black and white image and 3D image. 3D basically means three-dimensional image, that are three channels are there, RGB. After that, we have seen the convolution operations. We have seen the important features. Right now, I have told you that how machine extract the features. So you can see here from happy face, we have extracted the feature and we have created a input image of pixels. You can see here, this is a 7x7 matrix. Then we have seen that how we have converted the 7x7 matrix to 3x3 matrix. Hello. Nikhil Sharma, sir, please say him to off his mic. Hello.
स्वतंत्र सर
Shiv sir. Hello.
yes ma'am.
Sir, please say this participant to off his mic or.
Okay.
Okay, sir. I think
Okay, thank you,
there
sir.
will be a participant.
Okay, thank you.
Nikhil Sharma. Okay. Yes ma'am, continue.
Hello. Yes. So what we were, where we were, I was telling you that we have created an input image. From that, we have performed a feature detector on that, and we have created a feature map from that. हमने feature map create किया था. After that, we have created a feature map of 5x5 matrix from the input image of 7x7 matrix. After creating that feature map, we have seen that feature map is having some of the negative values. So what we have to do, we have to again perform an operation to remove these negative values. We can't remove some of the values from an images. So what we have done, we have rounded off the particular negative values to 0. So that operation is known as Relu operation. I told you that what we are going to do, we are going to remove the negative values from our feature map, and that particular thing is known as Relu operation. After performing the Relu operation, what we have done is creating a max pool layer in the particular thing. Why we have provided a max pooling layer? We have created a max pool layer to the particular feature map so that we can find out the most important features from the image. If an image is either tilt or a blurred image, or the particular image is not proper, we can create some of the we can find out the important features from the images. After creating the particular max pooling layer, or we can say we have created the max pooled features from this particular thing, we have flattened the particular data. Why we have flattened the data? So that we can provide the particular data to the fully connected layer. We have provided the data to fully connected layer, and then what we have done, we have made the predictions based on that. Predictions is based on the number of probability, or we can say the particular number of values which are coming in the particular neurons. If a particular model is predicting that it is 90% accurate, then we will go with that particular neuron. We will move forward with that particular neuron. And if the neuron is not predicting well, we are going to left it behind. And through this, we have find out the predictions that what a particular input image is showing us. So this was the particular convolutional neural network, and the applications also. I have told you some of the applications of real world also, that how in day-to-day life and real world we are implementing this particular network. And this is the particular architecture today we have understood of convolutional neural network. Now, any doubts if you are having on this particular session, so you can ask me right now. Anyone, any doubts? Anything you are not getting, or anything you can ask me if you are having doubts. Hello.
Dear participants,
Okay, sir.
any question?
No, sir. No.
Okay. Okay, ma'am. I think there is no questions from participants' side.
Okay, sir.
Okay.
Okay, fine. So tomorrow we will start with implementation of convolutional neural network. Today we have understood the architecture and the theoretical part of this. From tomorrow we are going to understood the implementation and how we can perform binary classification convolutional neural network.
Okay. Okay. Thank you, ma'am.
Okay, thank you, sir.
Okay.
Thank
Thank
you,
you, ma'am,
everyone.
and thank you to dear participants.
Thank you, ma'am.
Okay.